like
All right, guys, let's
rap
start.
music,
Let's start
but
so
it
that we
has
can be
to
done
like-
because Emma has to go at 1:30.
Like,
Okay. All right, guys, so our objective today, we're going to maximize volume using polynomials. And that's just because this is a little bit tricky. You know, a lot of the stuff that you guys are doing, you can just watch a video on how to, and you can solve the algorithms. But this is just a little bit different because you have to create some expressions. So that's what we're going to do today. So let's actually get started. It's not that bad. So here's an example, very much like the example you guys are going to have in your class. We're going to design a shoebox.
ooh, what if we have our own design shoebox?
Saxon, you can pay attention to the screen for now. All right, so Saxon, you can be this person. This is, you can just type your name in any cell and you can be.
What if we have our own designed shoebox?
Oh, then maybe we could bring that in. It could be a demonstration. But you're going to design a different shoebox. And the maximum volume, or I should say you're going to maximize the volume. So what you want to do is you want to make the biggest volume possible on the inside. Saxon, come over here.
Yeah,
That's
that's
okay.
a bit
The biggest volume possible, because that way you can put as much stuff in it as possible, but you have some kind of restraints or constraints, I should say. You have to keep the sum of the dimensions at a total of 23 inches. So that means length plus width plus height has to be 23 or less, right? And then they give you some other information. The length must be 4 times the height. So your question is, what should each dimension, length, width, and height be in order to actually maximize the volume? Let's close that out.
I'm trying to get brightness.
Oh, okay.
What does it have to be? Like, wait.
Wait, what?
What?
Restart that.
Yes, so I know that you guys are a little bit confused, so let me just restart it. You guys ready?
Sorry, yeah.
Are you guys paying attention?
My
So,
pen dropped.
our goal, think about our goal, our objective is to maximize the volume of this shoebox here. We're designing a shoebox to get the maximum volume possible based on some constraints, right? So if we take the length of it, the length, plus the width, plus the height,
and then we times it all together.
well, that's how you get volume, times it all together. But if you add up those dimensions, you will get a total of 23 inches. That's the most amount of material you have,
Oh,
right?
So
okay,
that's the
no, I know
volume.
what we're doing.
Yeah, does that sound familiar?
Yeah.
So that's your cardboard limitations, right? That's all you have. And then here's one other thing, that the length, this distance, must be 4 times the height. Okay, so that's all the information you have. So what should each dimension be in order to maximize the volume? What I'm going to do is help you guys walk through how to do it. It's not that hard. It doesn't take that long once it clicks. Okay, so you guys know our objectives?
Kind of.
Yeah.
So wait, how do you do that?
That's not part of the objective section. Right now, I'll show you after. So in your notepads, you guys, here's what I want you to do. First of all, write in for number 1, what is the formula for the volume of a prism? What is it in general?
Didn't you just say it was 24?
No, the formula. Like area is length times width, the area of a circle is pi r
B
squared.
squared, right? Isn't that
Times
that
weight
That's a triangle.
one?
LWH
For a
equals
rectangle?
volume.
Length times
Right
width?
there.
Yes.
Oh, that's the one, okay.
Okay, so good. So yeah, you guys, so write in your notepads. That's the first thing we need, right, is we need the volume of a prism, because this is a prism and we're maximizing volume, so we need to know volume. So if, for example, I'd given you one where it was a sphere, you would need to know how to calculate the volume of a sphere. Or if it was a cylinder, you would need to know how to calculate the volume of a cylinder. All right, Saxon, did you type in here yet?
Oh, I was. Oh, you meant
type
on
that
this
in here.
thing. Oh.
Yeah, let's see.
Why do I have
Oh,
a sad face? Who changed it to a sad?
that was probably you know who.
Alicia.
All right, so Emma, good. You're missing. Okay, so Emma, how many dimensions does that box have? Ah, very good, Emma. Yes.
Susan? Saxon's name is Susan?
That's his name for today.
Wait, who said Susan?
I called you that. Do you want me to change your name? Okay, look, I'm going to.
It's fine. It's okay. It's okay. Let Susan be Susan.
No. Oh my goodness. Saxon is.
Well, she
Sally.
changed it. What did
You should put Sally.
I'm Sally now.
No, I'm changing you to Saxon.
I'm Sally the guy,
You
guys.
are
Should I
Saxon.
already put him to Susan in his box?
Is it all girls in this webinar? I think
Okay.
it's all girls in this webinar. I'm the only guy.
I know, Saxon. Now pay attention. Okay, so Miriam, good. Length times width times height. Okay, so you guys are all good. Alicia, you're missing one dimension.
I know.
And then who's in the? Oh, Brianna, yes. Okay, so Brianna, you're already, okay, wow, Brianna, you are way ahead. So we're going to see if you are correct. So we're going to slow down just a little bit. All right, you guys, here's what I want you to do now. So you guys all have number one. So number two, in your box, write length equals.
Equals.
So, and then write width equals and height equals.
Probably connection.naviance.com.
Very good, very good. You guys are on top of it. Now, what I want you to do is fill in the equation for any one of those. Some kind of an expression or even just a variable, but you can only use x. You can't use any other variables than x. See if you can fill in an expression to represent length, to represent width, and to represent height. I know this is your new part. This is the part that's a little bit hard. And you can only use x.
So
What?
x
Wait.
times L equals x.
Can't use L. Can only use x. So like if I told you the length was 10 and the width was 3 and the height was 5, you would fill in 10, 3, 5, right? But we don't know what the numbers are. We only have a little bit of information, so we have to take that information and create an expression.
Huh?
Create an expression. Like if I told you, okay, for example,
Must equal 23, right?
the total. So I'm going to see how you guys do.
7 times something equals. No.
But you don't need an, you won't
No.
have a number. So you won't just have a single number. You're going to have an expression. A little bit tricky. A little bit tricky. And you would want to use this information up here to help you with the expression. So,
Oh, that's definitely not
all right, so Emma, you can't use, oh, you said, oh, okay, never mind. You just put length equals width equals height equals. All right, let's see if anybody can figure, okay, so I know Brianna is like trying to figure it out or thinks that she might have figured it out. And we shall see.
it. Ah,
Actually, you don't have to have a number yet.
I know, but it's hard.
Do you guys need a hint?
Yeah.
It looks like Emma said she's confused. Okay, what if I told you this? We're trying to find the area of a piece of paper, and I told you that the length was 3 times the width.
So you do length times length.
You would do, yeah, so you would do, say that width is x, and so your length would be 3 times x.
Okay, so what? Oh, okay. So yeah, okay,
Mm-hmm.
but you can't.
Mhm.
So you can just use a random number though. So x times.
And so they tell you the length must be 4 times the height. So
Ah.
I'll give you guys another hint if you're still confused, but if you want to keep trying.
And it's what again? Length times the height, right?
Didn't you
just
type it on
said
your
that.
sales section? Didn't you just type that
You just confused.
in your notepad?
Oh, LWH equals.
So
line?
wait, we have
No.
to type in an equation that will equal the volume?
You only have to type in an expression that will equal length, width, and height.
X times
Who
X
said
times
you only
X.
have to?
Actually,
No.
don't spit your gut.
I know, it was coming out.
Just because you don't like it, no.
Is it X times X times X?
No, but that was a good guess. Okay, you guys need another hint, I think, maybe? Do you guys need another hint?
I think you should just show us an example.
Okay. All right, here, I'm going to give you a hint. Okay, everybody, under height, type x. So height equals x. Okay. So we're going to say that height, and I'm going to write it on here. Oh, maybe. Height equals, with a different color maybe. Height equals x. Okay, so if height equals x, the next logical one would be length. Length must be 4 times the height. So what should the length be?
4 times the height. 4 times X.
Good.
Really?
Put that in.
That's not hard at all.
Wait, what? I still don't re-explain that.
So think about this, Lisa, right? Height is x, okay? And your length has to be 4 times the height.
See, I was on the verge there.
So length
Oh,
would equal,
so that's okay. I was thinking about that, but then I was like, maybe I'm wrong. So we got to type in a number for length times.
an expression. Yes.
Okay.
You don't have to do, you're just typing in something for length. So I'm going to go over here because Saxon has
Jackie Vargas, please
taken my
come to the main
computer.
office.
All right,
Jackie
so
Vargas to the main office.
I see Brianna, I see Susan, who is actually Saxon. Good job, you guys, good job. So that is actually correct. So your length is actually 4x. Good, because your length is 4 times your height, and if your height is x, length is 4 times, right? Okay, Here's the hard one. You guys ready for this?
With
Width. So here's what I want you to keep in mind. What does the total of all your measurements have to equal to?
23.
Yes, 23. 23. So how much of that 23 have you used?
Sorry, what?
Yeah.
About 7.
Four. Four, right?
Well,
You're gonna multiply that
Yeah.
4 by
okay, you guys. How much did we use for length?
Wait, what's the name of it?
We used 4x.
Good. We used 4x. How much did we use for height?
None.
X.
X. We used X.
Oh, okay.
And we only have 23. So can any one of you guys that are geniuses, I know you guys are all geniuses,
4 times something equals 23, huh?
but we have
3.
23 feet or 23 inches of cardboard.
3.
No, it's not a number yet, Katie.
Why?
We have 20.
example.
Okay, you guys, look at my hands, right? Okay, so you have 23 inches of cardboard, right? And then we used 4x, so that's some amount gone. Then we used an x, that's some amount gone. So I'm gonna draw a picture actually on here. That'll be better. Okay.
So we're gonna use like a line.
Well, no, like okay.
Yeah.
Like XX?
Well, wait, why isn't this drawing? Ah,
My brain hurts.
okay, so hang on. Something's not drawing. Probably Saxon, did you mess this up?
I didn't touch it.
Okay, you guys, up here, this is my cardboard, right, that I'm going to cut. So I'm just going to call this first part X, right? And then I'm going to call this longer part 4X. So it kind of looks like that. So I need to know how to get this. And didn't you guys say that the total from here to here was 23? Or didn't the problem say, I should say?
Yeah.
So can you guys write an expression to show me what this question mark is right here? That's,
So you just need that question mark.
that's all I need. That's all you have to give me. That's the question mark.
So what times what equals 23?
Justin Baxter, please come to the
Am I
main
doing
office.
times? Let me see what
Justin
Saxon say.
Baxter to the main
I haven't
office.
said anything yet.
Oh.
I'm just thinking. We gotta think. Stop messing with my stuff.
All right, guys. What if I gave you a simpler one? What if I gave you something that's going to make sense? Let's just say we have. Let's just say I put numbers on it. Okay, let's just say the whole thing is 23, and I'm just making this up, so don't use this. But let's just say this first part is 5, and this next part is 20. What would this question mark be right here?
20.
Oh, wait,
Are
sorry.
we adding? Are we
Sorry, 28. Otherwise, it won't make sense.
Are we adding? We're pressing, so it's a plus. I thought it was multiplication.
I thought it was
It's definitely
multiplication too.
Well, you guys look
Yeah.
at the little diagram. Would you multiply to figure out the question mark on that bottom one?
You don't know that. So. you
Length
can't tell.
times width times height.
That is volume, but we are not finding the volume yet.
We're finding
So-
width.
We're just finding the width.
So that would be length plus height.
4 plus 19. Duh.
Just like
Mm-hmm.
length is width plus height. Or divided by height or something like that.
Oh, Emma, 5. Okay, so Emma got 3. Perfect. That's the right answer, Emma. So how did you get 3 though? Did you add,
I
subtract?
told you it was 3.
She did say that.
She
I
Well,
did.
no, that's
She
not the
did.
answer. That's just the answer to the little practice problem I have down here
Oh.
in red.
Oh,
That's what Emma's doing. So Emma added.
Oh.
Is my other answer right? Oh, the 3 or Emma, did you say 5? Oh, on your notepad. Sorry. See, Saxon took over my other computer. Now I can't read you guys' notepad.
That's right.
Wait, let me look at what Emma put. Oh, wait, here, let me
It's
just.
right there. She
she
said
put
19.
Oh, 19.
I put 19 too.
Okay, so no, you guys, not 19.
But that would equal 23.
It's
No, but we don't know what X is. So how do you know how much you took on, how much you took off here?
Can it just be X?
Well, it can just be X.
Okay, then.
But
It's,
no, but the answer's not X because.
no, I'm saying like 4X plus 4 plus X would equal 5X.
Oh yes, that's true. Very good.
And then it would.
I like that.
Yeah.
Okay, so here's what Saxon has. Okay, so you guys, I'm
Wow.
gonna help you out now because I think you guys are starting to get it. All right, so we have 23 total, right? So my width is going to be equal to 23, but what have we already used? What are we going to subtract? Saxon, what did you just say? What are we going to subtract?
We're gonna subtract X.
Just one X?
No, 2X.
Just two X's?
What the-
How many X's did we
4
use?
X's. 4 X's.
4 X's?
Uh-huh.
Did we not use more than 4 X's?
We used the other X too.
So
So we're
how
gonna
many?
subtract 1X. the equal x. I'm trying. It's.
Actually a lot of X's going on. Okay, guys, look at this diagram up here at the top. How many X's is this in pink that I just did like that? How many X's total? How many is that?
That's all I can do
That is 2,
Okay, Katie, how much is this one that I'm circling?
4,
Okay, and how much is this one?
1,
How
5.
many? 5.
So
Exactly. Didn't you say
5x.
five? So width is
now. It's. Oh, because it's 5. Because there's 2 x's. Yeah.
all right, you guys. So this is the hardest part of this, right? Everything else you guys already know how to do, but so from this story problem, this contextual problem, we just name one of them X, and then we go with that for length. So our length was 4 times our height, and then what's left over is our width, and our width is the total of 23 less what we've already used, and we've used 5x. Yes, Emma, good job. You have it in the notepad. I see it. Okay. All right, you guys. So we are good to go. All we have to do now is just multiply everything together, right? Length times width times height. Didn't you guys tell me that it's length times width times height?
That's what the problem said.
So we'll see if Brianna has that right. So we have 4x. I'm going to put it all in parentheses, right? Times x. And this is what you guys already have done. You've multiplied
No,
polynomials.
It's 4x times 5x times x.
Where are you getting the 5x?
Width.
The width is 23 minus 5x. So be careful about that. So 4x times x is 4.
4x squared.
Nice job. And then we would multiply that times 23 minus 5x. So
23x
How'd you
squared
get
minus
23?
5x squared. No. You said, what was it multiplied to? I got the first one right, but it was
how about 92x squared? Because I know you guys can multiply.
yeah.
Minus 20x cubed. What kind of polynomial is that? Who can tell me? Quadratic. What is it?
Wait, what?
Oh, bye, Emma. I'm sorry you have to go. We're just going to graph this, and then we can find the x value. So you can just watch the very end. Is this a quadratic? Is this a cubic? Cubic. Emma, I know why you said quadratic because of that first squared, but notice that there's a cube back here. So it is a cubic. Now look what happened, you guys. Last step, since Emma's going, maybe Emma will still be here 2 minutes. So here was our length, width, height. We multiplied all those together, and I graphed that cubic that I wrote over here, which was, let me go back.
So there's a certain way to
Negative-
graph will work. No?
Well, I just did this. I put 20, because here's what we got when we multiplied it all together, right? 20x cubed, I don't have a good memory, plus 92x squared. Actually, this is minus. Plus 92x squared. So what I did is I just graphed that at Desmos, and that's what I got. So you guys, let me ask you this question. Everybody try to answer.
Okay.
What x value will maximize the volume based on that graph? How'd you get 3?
I can't read the graph. It's too little.
Really? Okay, guys, click on that to make it full screen.
No, would it be 5?
No, I think you were good.
No, it's 3.
Good, Brianna. Good. It's 3. It's 3.
It's
So if x is 3,
Oh, because it's 3 points. Okay, yeah. Now I see it. Now that I have to pull it all close to my face.
so Brianna, you said 288 was the maximum volume. So I don't know how you did that so fast, but nice job, by the way. So your x value is 3. That means your height is 3. So your width is going to be 23 minus 15, right? So that's 8. And your length is going to be 12. Brianna, I think you said that.
Yeah, she's already ahead of all of us.
I know.
Dang.
Brianna, seriously, I don't know how you did that one already so fast, but congratulations. Nice job. And good job to you guys, too. Very
I
nice.
think the congrats should go mainly to me.
Mainly to you, Saxon.
Mainly
Definitely.
to Susan.
Yeah, I guess I'm
And your fake
Susie.
name. Okay, so do you guys feel good about that? So what you do is the hardest part is you come up with your expressions, multiply them together to get your volume, graph it, and then the graph has all your answers.
Okay.
Okay, so any questions, you guys? Any questions? I'll go check my notepads to see how you guys are doing.
Well, you can see.
Minnie, Jenny, Math Jenny,
Math
Genie.
Oh,
Yeah,
Math
I
Genie.
don't know how to spell genie. I'm
Math
sorry.
Genie. How? No, Alicia.
I did not type that in.
What did
That
you
was
type?
not me this
Saxon.
time.
What? I didn't type.
That
type
was a
anything.
that's someone
What did
from
you type?
another room.
Nothing.
What
So-
was it?
Someone typed it
Did
Mary
you
J
record?
as your name.
All right, you
I
guys.
did not do that.
I believe you, Alicia.
I was putting Susan the whole time. I did not change.
All right,
my
guys. How
name
about
to
this?
Susan.
Let's do a quick check. Raise your hand if you felt good about that.
About what?
Okay, so that's good.
Look
Brianna,
at Mr. Rich raising his hand with me.
I see it. I see it. I see Brianna. I see Miriam. I see Alicia. Katie. I see something else.
Ah, that's not
Who's
supposed to
Lol
work.
Nope?
That's not. I meant to do that.
I think that's Saxon. Saxon, how do you feel?
That one was me. I feel good on this. Yeah. Well, I mean, it was really confusing at first.
And now you are in the money.
I'm grabbing the money. Yeah.
All right, you guys. Here's your ticket out. Are you ready for your ticket out?
No.
Yeah.
Okay, and now is the time to ask if you don't know. Describe how the graph, Saxon, how the
Yeah,
graph
Saxon,
of a
thank
polynomial can help you find the dimensions of an object for a maximum volume.
Huh?
How
the point
can
shows you how far it can go.
Okay.
Yeah.
describe how the graph of a polynomial can help you find the dimensions of an object? So yes, you're on the right track, exactly. Exactly what we
Because
did
it
on our
shows you
graph
the
part.
maximum
And I'll go
amount.
back to this graph while you guys are doing this so you can see.
That definitely makes sense.
Here's our graph.
It doesn't make sense. to
How
do
does
it.
this graph help you find the dimensions of something if you,
You
want
just
to maximum?
circled
Because the highest point. Because the highest point on the graph. That's it. That's as far as it goes.
I know.
Highest point on.
I don't
the graph.
understand how you don't understand that.
Cause
All right, you guys. So I'm gonna leave you with that ticket out, but I will be here to help.